Hello everybody and welcome to Blockchain Expert. In this video, I'll be walking you through a project where we will write and deploy an ERC721 token contract. After deploying this contract, we will then mint unique NFTs, and I will show you how we can create unique NFT data and store that on IPFS, which is the Interplanetary File System, which is really a decentralized file system to kind of make sure our assets are secure and not stored on any centralized server. After going through this project, you will understand how NFTs work, how to mint and create NFTs, and then how you can view all of the NFTs that a specific address has. In the next project, I will show you how we can set up an NFT auction and actually transfer NFTs around, purchase NFTs, sell them, add bids on NFTs, etc. Anyways, I hope you guys are excited. Let's go ahead and get started. So in front of me, I'm on the OpenZeppelin documentation, just like in the last project. And I'm going to quickly run you through the protocol for ERC721. So just like ERC20, OpenZeppelin has some base contracts and interfaces that we can use that make it easier for us to get started with these tokens. So let me click in here to the API reference and we can have a look at all of the methods on our ERC721. Okay, so first of all, this is kind of the base contract that we're going to inherit from and then use all of the functionality that's already written for us. And then we can override any of that we'd like, just like the ERC20 token. Okay, so looking here, we see that the required interface of ERC721 compliant contract is the following. We need balance of, owner of, safe transfer from, approve, get approved, set approval for all, is approved for all, and safe transfer from. Now, understand here that when we use ERC721, each token is unique. So every single token is going to have a unique ID, and that means that this works a little bit differently than our ERC20 token contract. With ERC20, since all of our tokens were fungible, we didn't really have a notion of a user owning a specific token. They just had a balance of a certain amount of tokens. So here, whenever you see token ID, that's representing the individual token that this user owns, and they can own multiple different tokens with different token IDs. So balance of is going to tell you how many different NFTs this owner has, so how many of these tokens they have access to. Owner of is going to tell you what the address of the owner of this token ID is. Safe transfer from is going to do a safe transfer from an address to an address of a token ID. And the reason this is called safe transfer from, if we click into it here, actually, I guess it's not going to give me the description, is it? Actually, let's go here. Maybe it will. Safe transfer from safely transfers the ownership of a given token ID to another address. If the target address is a contract, it must implement the ERC721 receiver, which is called upon a safe transfer, and return the magic value of this, which we can talk about in a second. Anyways, what this safe transfer from method does is ensure that whoever we are transferring this token to can actually accept the token. If it can't accept the token, then it's not going to perform the transfer. And as it kind of briefly stated there, to be able to accept an ERC721 token as a smart contract, you have to implement a special method, which we're going to look at in the next project. Anyways, that is safe transfer from. You then have transfer from. You're not supposed to use this. You're supposed to just use safe transfer from now. Then we have approve. This is the same as approving an ERC20 transfer, except in this case, we are approving a specific address to be able to send this token ID on our behalf or to transfer that. Get approved. This tells us which address is approved to actually transfer this token ID. Set approval for all. This means that some operator contract, or really just whoever, has the ability to approve every single one of our token transfers, so it can do all of our NFTs. Is approved for all. Same thing tells us which address has access to that. And then another safe transfer from, but this safe transfer from would be used by one of the operator contracts that has approval to do a transfer on your behalf. All right, I know that was a lot, but that is the ERC721 token interface. Now, let's go down and look at what's actually on ERC721. All of our underscore methods are the internal methods, which we can only call directly on this contract. So we have, for example, safe mint, burn, transfer from, etc. And these are going to be pretty much the exact same as all of the methods we saw on our ERC20 token contract. Now, the difference here is that when we are minting a token, you can see we have safe mint here, right? We can actually associate specific data with this token. And that data is actually going to be a URL, and that URL will be the IPFS kind of a link to where our metadata is stored. Now, you can also store metadata directly on the smart contract. However, that's going to be very expensive to do because oftentimes you have images or kind of large files that you want to be associated with an NFT, maybe even videos, for example. In that case, it's unfeasible to store them on the blockchain. Instead, you store them kind of in a third-party place like IPFS, and then you link them by kind of giving the IPFS URL. It's not exactly a URL, it's something known as a CID, but we'll talk about that later. Okay. Apologize for going through this such in depth. I know you guys want to get started with the project, but I just need to explain this before we can go much further. Next thing we want to look at here before we jump into code is Minty. Now, Minty is a great tool here that's going to make it very easy for us to actually store data on IPFS and to link that to the data that is associated with NFTs in our token contract. You'll see how this works in a minute, but I just wanted to illustrate that this is what we're going to be using, this thing called Minty. And you can see there's kind of some install steps here. And there's a way, if we go down here, to actually just run a command like Minty, mint, you mint a specific kind of metadata file. You can have a name, a description, etc. And then what it will do is actually call the correct smart contract methods and upload your data to IPFS. So then you have access to it in a decentralized fashion. Okay, so that's it for Minty. We'll look at that in a second. Next, we have IPFS. Now, as I was saying, IPFS is the Interplanetary File System. Now, as it states in this little description here, this is a decentralized file system for building next generation of the internet. Now, what IPFS really does is it runs just like a blockchain network on many different nodes or computers around the internet, and all of these computers store different data in a decentralized fashion. This data could be a file, this could be a video, this could be a picture. Really, anything that you want to be stored in a decentralized manner, you use IPFS to do. There's a few other things you can use as well, but IPFS is probably the most popular one to date. Now, the reason why we need something like IPFS is that when we are creating NFTs, ideally we want to have unique data associated with our NFTs. Now, as I said at the beginning of this video, it's very infeasible to store large data on the blockchain. We just really can't do that, or if we did, it would cost us a ton of money. So instead, we need a safe location to store this data where we know it cannot be manipulated or changed, and it can't kind of become unavailable, right? It can't go offline or not be available in the future. So that's why we use something like IPFS. Rather than having a central server that could crash, or that could be hacked, or that we could change an HTTP endpoint on, or that we could modify data on, we use IPFS, and IPFS has many nodes around the world that are all storing copies of the same data, making it highly available. Now, there's a few nuances with this that I'll talk about later on, but essentially think of IPFS as a blockchain network for storing files, storing larger information. And what we're actually going to do here is we're going to download IPFS onto our computer and run a local IPFS node, which is going to store our NFT data. If we wanted this to be kind of transmitted out to the network and stored persistently, we would do something known as pinning this data, where we essentially use a third-party service that runs a bunch of IPFS nodes, that then kind of copy our data and store it on IPFS so we can always access it. So whenever you see popular NFT projects, chances are they're using IPFS to store all of the NFT metadata associated with, well, the NFT. So what we're actually going to do here is install IPFS, and to do that, we are going to click on the link on the left-hand side here and go to command line. Now, if you want to see the URL, it is right here. You also can just Google IPFS and then find kind of this navigation menu here. But we want to install IPFS through the command line because we're going to be running an IPFS node locally that we can connect to. Now, I won't lie to you, this setup is a bit complicated. Now, you should be able to get through it by just following the instructions, but I'm not going to run you through installing this because it's just a lot of really copying and pasting from this website, and it's going to differ depending on the operating system that you're on. So please take your time, go through the different installation steps that it gives you here. I know it looks a little bit intimidating, but if you run through this exactly as it says, you should be able to have access to IPFS from the command line. So again, go through the installation steps for your operating system, take your time doing that, and then once you are finished, we can kind of continue on with the rest of the video. All right, so I'm going to close Google Chrome now, and I'm going to go into VS Code and make sure IPFS is installed. Now, if you followed the Windows installation, then you're going to see that you need to use PowerShell from VS Code to access this. So I'm going to change my terminal to be PowerShell by clicking on this little down arrow and going to PowerShell. And I'm going to type IPFS -- version like this. Okay, so that should work, and the reason that should work is you're saving a PowerShell profile that should be automatically loaded for you every single time you open up PowerShell. So just make sure you're using PowerShell and not command prompt, otherwise you're going to get an error. You can see if I go here and try to use IPFS, it says command not found, but in PowerShell it works. Okay, so now that we have that installed, what we actually want to do is we want to clone the Minty repository, and that's where we're kind of going to be working for creating our NFT contract. So let me go back here to Minty. Now, this URL you can see is github.com/whatever this username is /minty.git. Now, if you don't want to actually clone this, you can just download the code from GitHub. I'll already have this cloned for you, and you can kind of delete the contracts and work on them from scratch if you want to. Or additionally, you can pause the video, write this out, and clone this repository using Git. So I'm going to assume that you have Git installed. And I'm going to type here git clone, and then I'm going to clone this URL for the Minty repository. Okay, so now I have this Minty directory open, and this is what we're going to be using kind of for the rest of this video for our project setup. So quickly, let's just have a look inside of Minty. I'll zoom in for a second so we can see this a bit easier. Notice that we have a hardhat.config.js file, and what this actually tells us immediately is that we are using Hardhat for this project. So just keep that in mind. This is a Hardhat project, which we already know how to work with. So when we want to, say, deploy the contract or run our node, we're going to be using those Hardhat commands that we've seen previously. Okay, so what we're going to do now is we're going to cd into this Minty directory, and we're going to install all of the dependencies that we need. So we're going to start by typing npm link. This is just a command that we need to do to link some of our packages. We're then going to type npm install, and this is going to install all of the dependencies for this project, so I'll be back once that is finished. All right, so all of the dependencies are installed, and what I'm going to do is now click in and show you some of the information in Minty. So first of all, let's go to contracts here and look at minty.sol. Now, this is kind of a base NFT contract. Now, obviously, if you were working on a larger NFT project, you'd probably be modifying this a bit. But for our use case, this is actually exactly what we need to get started working with NFTs. So I'm not going to modify this contract at all. I'm just going to keep this kind of base contract that we have. And I'm going to show you instead how we kind of connect with IPFS, how we deploy this, how we use a front end to actually interact with this contract, etc. So here, if we just quickly have a look at the code, we can see that we're using this kind of counters utility function from OpenZeppelin. And what this does is just ensure that we have a unique ID for every single one of our tokens. We then have a constructor where we take in a token name and a symbol, and we pass that to the base contract so it can set that information. We then set the base URI, which is IPFS:// because it knows we're going to be using IPFS to store all of our NFT metadata. We then have a mint token function, and notice here that this mint token function doesn't have any access controls. So anyone is able to call this function right now because it is public. We'll leave it like this for now, just for this project, but later on, you would probably want to add access controls here and require that maybe only the owner is able to do this, etc., right? Now, when we are minting token, we can see it says address owner and then the metadata URI. So the owner is who we want to give this token to. And we call safe mint and then set token URI to do this. Okay, so that's really it for this contract. Feel free to look through it more if you want, but I'm not going to get into that anymore. Let's quickly go into SRC. So inside of SRC, let me zoom out now, we have a deploy script. Now this deploy script is already written for us, and again, we don't need to do anything here. We should be familiar with how this works from the previous projects, but this will automatically deploy our Minty token contract for us, and it's going to do a few other things like saving deployment info, like we did in the previous projects, validating deployment info, all of this kind of stuff. Okay, we then have index.js, containing some kind of command line functions and tools that we can use, which we will actually be using shortly. And then here we have Minty.js. Now inside of Minty.js, this is the Minty class that is used by our command line tools to actually be deploying, adding stuff to IPFS, etc. Again, don't really need to understand this or walk through it. Just wanted to show you what exists here. All right, now continuing here, we have a test file. Now, we don't really need this test file, and in fact, this is actually not a valid test for this project. I don't know why they even have this here. So I'm actually going to delete this test directory because we no longer need this. Okay, there we go. That is a basic walkthrough of Minty. Now, we'll use Minty just to kind of fast track us here for our project, and actually let me show you how we get started with this. So the first thing I want to do here is actually grab some data that I want to associate with an NFT. Now you can make this data anything you want. It could be a JSON file, a text file, a video, it doesn't matter. In my case, I'm going to go with images. So inside of Minty, I'm going to create a new directory here. So let's go inside of Minty called assets. And this is where I'll place some of the assets that I'm going to use while I mint my NFTs. So I'm just going to grab a few images from Google Images, and then I'll be right back. All right, so as you can see here, I have a few assets. I have bear.jpg and tiger.jpg, and this is what I'll use as my NFT assets. Again, use whatever you'd like. Now, there is a command here inside of this Minty tool that should kind of set everything up for us that we need before we can start actually minting NFT tokens. Now, this command or this script is start local environment.sh. So you can run that and see if it works for you, but for me, it's not worked. So I'm going to show you how to do this manually so that we don't have to rely on this script just in case it doesn't work for you. So what we need to set up here is the following. We need to run our hard hat node. We need to run our IPFS node, and then we need to deploy our token contract, and then we actually need to mint our NFTs to that contract. So the first thing that I'm going to run is my IPFS node. And the way I do that is I say IPFS, and I believe this is pronounced daemon. So I'm going to type daemon here, and it should start IPFS. Okay, so it says the daemon is ready. Perfect. All right, now that is running, I'm going to split my terminal. Okay, so here I'm going to run my hard hat node. First, I'm going to cd into Minty, and then I'm going to type npx hard hat node because hard hat should be installed in the Minty directory. Okay, so it says that this node is actually already running. That's interesting. I might have had it running from another project. So let me shut that down and then restart it, and I will be right back. All right, so I got my hard hat node running here. I guess I just had the process in the background, so I had to shut that off. And you can see that now I have all of my keys, and well, the node is running. Now, what I need to do is open another terminal. So I'm going to open a new terminal here. Notice these two are connected. They're kind of split with each other, and then I have another command prompt here. I'm going to cd into Minty, and I'm going to deploy my smart contract. Now, to do that, I can actually run the hard hat command that we've seen before, where we deploy to the local network using the deploy script, or I can use the command Minty deploy. Now, this should work from inside of the Minty directory, but if for some reason this Minty command does not work for you, then you can try the following: npx hard hat, and then this is going to be run. Then you're going to say -- network localhost, and then this should be /scripts, and then /, and then I believe it is deploy.js, just like we did in the other projects. And that should do the exact same thing as what Minty deploy just did. Okay, so we can see here that this deployed the Julep JLP token to the network localhost. Now, if we want to change the name of the token or the description of the token, the way we do that is Minty deploy, and then -- name. I could do name, say animals, and then I could do -- symbol, and then we could do maybe ANM or something like that. Now let's see if this actually works. And you can see that it's going to tell me that it is deploying animals, ANM to network localhost with this address. It's just saying that the Minty deployment.json file still exists. So do I want to override it? Yes, I will override it. Okay, so now that's been deployed, and if I go and I look at hard hat, I can see that I've deployed the Minty smart contract, and I have the contract address, transaction ID, and all of that information. Now, if I go to Minty deployment.json, you can see that it has information about the contract that was just deployed. Okay, so I know this is a lot of steps here, but this tool saves us a drastic amount of time. Now I'm going to clear the screen, and I'm going to show you how we mint an NFT. Again, just to recap, at this point, we have started our IPFS server, we have started our hard hat node, and we have deployed the contract. If you shut off either of your nodes here, or specifically the hard hat node, you're going to have to restart this process and deploy the token again. Okay, so just keep that in mind. So now the way that we actually mint our token is we say Minty mint, and then we put first of all, the location to the asset that we want to be associated with our token. So an image, a JSON file, whatever you want it to be. In this case, I want it to be an image. I want bear.jpg to be a part of this NFT. Now, I will note that if you wanted, say, an image and a bunch of metadata associated with your NFT, then what you would need to do is you would need to use a JSON file as the asset that already had linked the URL to the IPFS asset that you have stored. Hopefully that makes a bit of sense, but essentially if you want a bunch of information like the asset as well as maybe a bunch of metadata characteristics, then you'd have some kind of JSON file or some other metadata file, and inside of that metadata file, you'd have a link to where the image is stored, ideally on IPFS. Okay, so I'm going to type minty, mint, and then this is going to be ./assets/ and then bear.jpg because this is the first NFT I want to mint. Now that I do that, I'm going to hit enter. And it's going to prompt me to enter a name for my NFT as well as a description. You can leave these blank if you want, but I'm just going to put in a name. I'm going to say bear. And I'm going to say this is a bear. Okay, now I have minted my NFT. Now notice here that it gives me the metadata address, the metadata gateway URL, and the asset address and the asset gateway URL. So what actually happened here is that Minty automatically minted a JSON file for me and added this to IPFS. And as I was saying, inside of this JSON file, I have an image, and that is the image here on IPFS. And then I have my name and my description, which is metadata associated with this NFT. So what I was saying is to do something along those lines. Now, Minty automatically does this for you, but it only includes the name and the description. So if you wanted to, you could go into index.js and you could modify this here so that you ask for more than just a name and a description. And then when you actually create the NFT, which you would do with this line right here, where you kind of have to dig into the code, you could add additional metadata information. So now what I'm going to do is I'm going to copy the metadata gateway URL. And notice that this starts with localhost. Now, the reason it starts with localhost is because I've kind of deployed this to IPFS using my IPFS node. Now, what my node is automatically going to do is transmit this out to the network, and any other nodes that would like to can then grab this data and store it on their machine, hence making it decentralized. However, there's nothing to guarantee that they're going to do that, which is what I'll talk to you about in a second. Anyways, for now, I've copied that gateway URL. I'm going to paste that into my browser, and notice that it brings up my metadata. So I have my name, my description, and my image. And then if I copy my image and I paste this here, okay, I have IPFS desktop installed, so it wants me to open that. But if I instead, go back here and copy the asset gateway URL. Okay, let's go back to Chrome and let's paste this in. Then notice that I get my bear image showing up from IPFS. Okay, hopefully this is making a little bit of sense, but this is how we just deploy or mint a new NFT. Now, again, what this tool is doing for us is really optimizing this whole process so that we don't have to write all of this code ourselves that deploys this to IPFS. You can read through this code to see exactly how it works. It's actually not that long, but this saves us from having to do all of that. So now, if we go back here, we can see that we had a Minty mint token contract call, and we have minted a token to the address that we called this from, which by default is going to be the first address for our hard hat node. I know this seems a little bit confusing, but if we go right here, we can see account 0. This is the account that we would have used to mint this token. So you can see that this was called from, and this is the address of the first account. There is a way to change that, but we don't need to look at that right now. Okay, so we've minted this NFT token. It now exists, and it should just kind of be there, right? Like on our hard hat node. Now what I want to show you is how we see this NFT token from MetaMask and actually view that we have this. All right, so I've opened up MetaMask here, and I'm on the account that was used to mint this token and deploy the contract. So just the first account that's automatically created for you by your hard hat network. Now what I'm going to do is scroll to the assets section here, and actually, let's see, can I make this full screen? I want this to be larger because it's a bit harder to see. Yes, expand view. Okay, this should be better for us to see. All right, great. So assets. So for assets, we're going to go import tokens. And for the contract address, we're going to paste the contract address. It's automatically going to place our symbol for us. Okay, so now that we have this, we're going to put our token decimal at 0. Don't worry about this too much right now. And we're going to hit add custom token. And notice it tells me I have one ANM, so like one animal token. Okay, so I'm going to import that in here. And it's just saying I have one. Now, it's not able to load the image right now, and it's not really showing me like the metadata of this token, but it is telling me, hey, yes, you have one of them. It's getting that balance. All right, so now we can see that it's loaded that I have one ANM. If I click into this, there we go. It shows it to me, but it doesn't say I have any transactions. Now, that's about as much as we're going to get from MetaMask for this specific NFT token contract. All right, so now what I'm going to do is show you how we can write a front end that actually allows us to view all of the NFTs that a specific user has access to. The way we're going to do that is we're going to get out of this Minty folder. We're going to create a new folder called front end. And like usual, we're going to create our base.html file and our script.js file. So let's go in base HTML. Let's create our template here. I'm just going to call this NFT viewer for now. And let's import the script tag that we need to load ethers.js and connect our script, which is this file right here. Okay, so this is the tag that we need. Again, we've used this in a few projects. I assume you understand how it works now. And now that we have this, let's write just a very, very basic front end that allows us to kind of connect to MetaMask and then view all of the NFTs. So first thing I'll do here is I'll say div, and kind of similar to the last project, I will say class is equal to container. So let's copy that and paste that inside of here. We're going to make another div. Class can be equal to our row. And then inside of here, we can say div class is equal to item. And we can say the number of NFTs that a specific user has. So I'm going to say number of NFTs like so. And then we'll put a span tag here, and we'll say ID is equal to num NFTs. And let's put that inside of the quotation marks. Okay, now let's make a button, and this will be what actually loads the number of NFTs. So I'll say on click is equal to get all NFTs. Okay, and then we will say update NFTs. All right, now I'm going to make one more div here, and I'm going to say the ID is equal to NFTs, and this is where we're actually going to place all of the images and the metadata of our NFTs. Okay, believe it or not, that's actually all that we need for the front end right now, although we will add some styling for our classes. So let me actually do that. And this styling is going to be the exact same as the previous project, so I'm not going to repeat myself by writing it again. I'm just going to paste it in here. So we have our container, our row, and our item. Feel free to pause and copy this out. Obviously, you can just grab it from the last project or from the GitHub code associated with this project. Okay, so now that we have that, let's go to script.js and let's start writing what we need here for interacting with our NFT contract. So like before, we're going to say const provider is equal to new ethers dot, and then this is going to be providers dot web3 provider, and then this is going to be window dot Ethereum. Next, we're going to say let signer, and we will assign the signer in a minute. And we're going to say const token ABI is equal to, and I got to spell this correctly. We're going to paste in the token ABI from our deployment info. So let's grab that and paste that in. Okay, next we want the address. So I'm going to say const token address is equal to, and then I'm going to copy the address here from the deployment info. Okay, and then I'm going to say let the token contract equal null. Very repetitive so far as to what we've done in previous projects. Okay, now I'm going to write my function again to get us access to MetaMask. So I'm going to say get access, and I'm going to say if the token contract, then I'm going to return because I've already initialized this. Otherwise, I'm going to say await provider dot send eth underscore request accounts, and then we will put a empty array here. Then I'm going to say signer is equal to provider dot get signer, and I'm going to say that the token contract is equal to new ethers, if we can spell this correctly, dot contract, and we need to pass the address. So let's go token address, the ABI, and what else? We need our signer. Okay, so that's all we need for get access. Now, the only function that we need to write here is actually going to be called get all NFTs. And when we press that button on our front end, it's going to call that function and update all of our NFTs for us. So I'm going to say async function get all NFTs. I think that's how I spelt it. And then inside of here, we're going to await get access. Okay. First thing we want to do here is we want to get the number of NFTs that this user has. So the way we can do that is we can say const num NFTs is equal to await token contract dot balance of, and this can be the balance of await signer dot get address. Okay, then we're going to say document dot get element by ID, and I believe I called this num NFTs dot inner HTML is equal to the number of NFTs. Okay, before we go any further, let's make sure this works. So let me just see if that is what I called it. Num NFTs. Okay, let me copy this and change the ID here. Okay, it looks good to me. Now let's run our live server. Okay, so let's go live and let's ensure that this is working. Okay, so we're going to go inspect here. Going to go to the console, update NFTs, and notice that I have one. The reason I have one is because my MetaMask account right now is the account that we minted this NFT to. If I change to another account, it should say 0. Okay. Now that we have gotten the number of NFTs, what we want to get is all of the NFT IDs. Now, the way that we get the NFT IDs is by using a special method called token by index. Now, look here and see we have token by index. Now, what this does is give us the ID of tokens that we own based on their index in the array that is in the smart contract that stores what tokens we have. So really, in the smart contract, we have some kind of mapping that goes from our address to an array, and then it has like 1, 3, 7, 8, 9, and these are all of the IDs of unique NFTs that we own. So we need to call this function here multiple times to get all of the different unique IDs of tokens that we own, because we don't know what tokens we own, we just know how many. If we know how many, though, we know how many indices we will have, and hence we can get all of the unique IDs. So I'm going to say const NFTs is equal to an empty array, and I'm going to say const promises is equal to an empty array as well. Now, the reason I'm doing this is that we're going to have multiple promises that need to resolve, because we're going to be calling this get token by index function multiple times. So I'm going to push all of the promises into an array, and then I can await for all of those promises after I trigger all of them to make sure this operation is as efficient as possible. So I'm going to say for let IDX equal 0, IDX less than the number of NFTs, and then IDX plus plus. And I'm going to say const promise is equal to the token contract dot, and then this is going to be token by index. Now the index is going to be IDX, and again, we go up to but not include the number of NFTs. So if we just have 1, then the index will look at a 0. If we have 2 NFTs, we'll look at 0 and 1, but we will eventually get all of the NFTs that we have. Okay, we're going to put a dot then here, and this is going to be the NFT ID that is returned to us. So once we have our NFT ID, I'm going to say const ID is equal to the NFT ID dot, and then this is going to be toNumber. Now, the reason we need to do toNumber is that NFT ID here is going to be the type of big int, this kind of a special value returned to us by ethers, and we need to convert this to a regular JavaScript number, so I use this .toNumber function. All right, so now that I have the ID, I'm going to go inside of here, and I'm going to say return token contract dot token URI. So now that I have the ID, I want to grab the metadata associated with my token. So I do that by using the ID of the token, which I now have. And then I say dot then, and I'm going to say URI. And then this is going to be NFTs dot push, and then the URI. So I will push all of these URIs into the NFTs array. Okay, there's a few other ways we can go about doing this, but this is the way that I think is the most simple for now. Now that we have our promise, we're going to say promises.push, and we're going to push this promise into the promises array. Now what I can do is I can say await promise.all and then promises, and this is going to await every single one of these promises. Now, the reason why I'm kind of using this format here is that one user could potentially have many different NFTs. So what I want to do is I want to loop, I want to create the promise that's going to get each individual NFT, and I want to kind of start the request to get all of those NFTs rather than waiting for each request synchronously. So by doing this, I'm kind of triggering every single one of the requests to start, and then down here I'm saying, okay, now that all of them have started, wait for all of them to finish, rather than saying, okay, give me one, wait for that to finish. Give me two, wait for that to finish. This is just a more efficient way to go about doing it. Okay, so now that I have that, before we get any further, let's console.log our NFTs and just make sure that this is working. Okay, so let's go to here, let's refresh, and let's go update NFTs and see here that it gives me my IPFS URL. Perfect, that's exactly what I was looking for. And if I were to mint another NFT, it should give me the second IPFS URL. Now that we have that URL, we're not quite done because we don't have the metadata. We just have the link to where the metadata is. So we now need to actually fetch the metadata associated with this URL. So the way we do that is we start by looping through every single one of our NFTs. So we say we're going to say const NFT of NFTs, and we're going to say const, and this is going to be link is equal to a function, which we're going to call get URL, and we're going to place here our NFT. We're now going to write a function down here called get URL, and we're going to put here IPFS, and I will return this in 1 second once I describe exactly what we're doing. So what we're doing with this get URL function is we are going to essentially kind of wrap the IPFS URL that we need with an HTTP gateway. Now, what a gateway allows us to do is access IPFS data from a location or software or whatever application that doesn't natively support IPFS. So native JavaScript and the fetch function, which we're going to be using in a second, is one of those applications. It doesn't let us just directly use this IPFS URL. So instead, we need to use a gateway. And you'll notice that when we minted the NFT, although it's kind of, I got crushed here by my terminal, but when we minted it, it showed us the gateway URL. Now, the gateway URL is going to be this. It's going to be return and then http://localhost, because we're connecting to our local IPFS node, which we know has this NFT data, and then /IPFS. Then we're going to say plus IPFS, and then we're going to say .split. We're going to split at the colon. So what I'm trying to do here is get kind of this data, and then we're going to say .slice1, and what that's going to do is remove one of these slashes. So what I'm trying to do is replace IPFS : with this, and then just one of the slashes, right? So we'll keep one of those slashes and then get the rest of the link. That's essentially what I'm doing here with get URL. All right, so this should be giving us the correct URL to grab our IPFS metadata. Now that we have that URL, we want to actually, well, get the metadata. So I'm going to say const JSON is equal to, and then this is going to be await fetch, and then our link. Now, actually thinking about it here, we can probably do the same kind of thing with our promises, where what we do is we kind of grab every single one of these URLs that we want, and then we await them all afterwards, rather than doing them one at a time, which is what this await keyword is going to do. So in fact, let's do that. I'm going to actually say let promises, just so I can reassign to this here. And then I'm going to say promises is equal to an empty array, so that I can then push this promise back in. So I'm going to say, rather than JSON, promise is equal to fetch link. Then we are going to have .then, and then this is going to be data, and we're going to return our data.json, okay? And then we're going to have another .then here, and we're going to say JSON And here we are, for now, just going to console.log JSON. But in a second, we'll actually put this onto the DOM. So we'll actually see the image. We can load that, see the name of the NFT, all of that kind of stuff. Okay, now I'm going to say promises.push promise. And I'm going to say await promises.all. And sorry, this should say promise with a capital P dot all. And then promises. All right. So that should be good. Just to quickly recap here what's going on. We get the number of NFTs. We then loop through and get each individual NFT as well as the URI for that NFT, which is really the metadata URL, so the link to where that data is. Then we come here, and for every single one of those URLs, we actually fetch them. So we grab what that URL is. If you're not familiar with the fetch function, it just sends a GET request to a URL. And then we are going to grab the JSON associated with that, which will really just be the metadata. And for now, we're just printing it out. Eventually, though, we will add it to the DOM. Okay, so let's go back to Google Chrome. Let's refresh, and let's call this. And we got an error. It says access to fetch at localhost IPFS // There was an error. Okay, I think the issue here is that we have 2 slashes. I was trying to get rid of one of these slashes here. So let me see what this issue is, and I'll be right back. All right, so this is a silly mistake here, but I have IPFS.split, and then what I actually want to do is grab the first index of the split data, and then say .slice. So if we have a look here, right, I'm saying IPFS : // I'm splitting at the colon, and then previously I wasn't actually accessing any index, so I was getting an error. Here, though, I want to access the first index, which is going to be all of this data, and then I want to slice this at index 1, which means I'm just going to get the first slash forward. Okay, so I just needed to add that here. So now that we have that, if I go back and I refresh and I rerun, we should see that we get our metadata. And notice we get that. So we have our name, description, and then we get another IPFS URL that is going to contain our image. Okay. So that is all good. Now that we have our metadata, we want to load that metadata and put that onto the DOM. Okay, so let's delete our console.log. And what I'm going to do is create a div where I'm going to place the image as well as the name and the description of our NFT. And then I'm going to push that into the NFTs div that we have in our DOM. So I'm going to say const NFT div is equal to document.create element. I'm going to create a div. I'm then going to say const image is equal to document.create element. And I'm going to create an image or img. I'm then going to say image.source is equal to get URL. And then I'm going to put my json.image, which is my NFT data image. I'm then going to say image.width is equal to 200. Just set this to a static value. And then I'm going to say NFT div dot append child, and I'm going to append the image. So I'm taking this image and putting it inside of this div. Okay, now we want to do the same for our name and description. So I'm going to say const name is equal to document.create, and this is going to be element, and we will create the element p. I'm then going to say const text is equal to document.create text node. And for this, we're going to put our json.name. I'm then going to say name.append my text. I'm going to say NFT div.append child, and I'm going to append the child of my name. Now I'm actually going to copy this, and we're going to do the same for our description. So we're going to say description here. We're going to append the child of description, and we'll just change this to say text2 and json.description. And then we'll append text2. Okay. Lastly, after we've now created our NFT div that has our image, our name, and our description, I now want to place this inside of the div that exists on my, on my DOM. So I'm actually going to go up here. I'm going to say const div is equal to document.get element by ID. And I believe we called this NFTs. And then I'm going to say div.append child. And I'm going to append the child of NFT div. Okay, So that should be good. I know that was quite a bit of code. Let me get rid of this console and we can kind of go through it. So again, we wait our access. We get our balance of our tokens, so how many NFTs that we have. We loop through here and we get the URI associated with every single NFT. We then go here and for every single kind of URI that we have, or the data that we want to access, we get the correct URL. We fetch that data. And then once we have the correct data, we create an element and place that onto the DOM that's going to contain our NFT image, name, and description. Let's try this out and see if this works. So I'm going to go refresh, update NFTs, and bear, this is a bear. Now, given I probably could have spaced these out a little bit better, but you can see that this is working and we can display our NFT data. Now, to truly test this out, let's mint another NFT and make sure it updates here on our front end. So let me go back to my terminal. Notice I'm inside of the Minty directory. I'm going to run this Minty command again, except this time, rather than bear, I'm going to do this with tiger.jpg. Okay, enter a name. We're going to say tiger, and a great description of this is a tiger. Okay, now this has been minted. And if I go here and I refresh and I update my NFTs, now I have my 2 NFTs, my bear, and my tiger. There you go. And one last check here. If we go to MetaMask and we have a look at our assets, you can see that it shows I have 2 animals. Okay. So with that said, that is going to kind of start to wrap up this project. Now, there is a few things I need to talk about with IPFS. So right now, the reason why all of this is working is because we are running a local IPFS node. Now, our local IPFS node, if we go back to it here, you can see is, well, actually it doesn't really say like what's going on in here, but this local node is what is storing all of our kind of NFT data. Now, if I turn this node off, our NFT data potentially could no longer be available. Now, it might be available, it might not, we don't know. And the reason we don't know is because we don't know if the nodes on the NFT, or sorry, on the IPFS network have gotten our data and are storing a copy of that. So the way you solve this problem is you use something known as a pinning service. Now, a pinning service is exactly what it says. It's a service that kind of pins your NFT data onto the IPFS network by running IPFS nodes that contain your data. It will run multiple of them in a decentralized manner, and it just ensures that these are going to exist on the IPFS network pretty much forever. So there is a popular pinning service, I'll load it up here, called Pinita. Now, this is actually free for, I believe, your first gigabyte of data, which is quite a bit. And what you can do if you want to use this pinning service is sign in here. You can kind of read through the instructions. It's very straightforward. And you just submit the data that you want to pin, and then it will make sure that it stays pinned. Straightforward. I'm not going to kind of show you exactly how to do that. Now, one other thing to show you or talk about is this gateway, right? So here we're using our localhost gateway because we know that we have a node running that runs IPFS. Now, obviously, we're not always going to be running this in kind of a dev environment. We might be running it in a production environment. And in that situation, you would want to be using the gateway of your pinning service or the IPFS gateway, which there's like a kind of a special gateway you can use that is provided by IPFS. Now, ideally, you don't want to use a gateway at all. You just want to directly access the IPFS URL, which a lot of applications can do. However, in our situation, we had to use this special gateway. So this is a little bit beyond the scope of this project. Getting into NFTs is obviously a bit complicated. There's a lot of stuff that you can do. And I'm going to encourage all of you to kind of do your own research and study this a bit more if you wanted to deploy your own type of NFT project. This was really meant to be kind of an introduction to the topic, show you the basics of getting it set up, how we would interact with an NFT contract, what IPFS is, kind of how that works, and hopefully that accomplished the goal. But again, there is more you would want to look into if you were going to be doing this in a production environment. We just don't really have the time and resources in this course to provide that as of right now. So with that said, I'm going to wrap this up. I hope that you found this useful, and I look forward to seeing you in another Blockchain Expert video.